Welcome back, students. Now, after that brief introduction, let's move on to the next session of this elective. And today we'll be covering about the main part of ground investigation, that is how to conduct a site investigation or a subsurface exploration program. So the subsurface exploration program consists of a sequence of events as shown in this flow diagram. So it starts with the basic desk study. That is, the engineer has to prepare himself and has to get acquainted with the particular site with all the materials available about the site. And then he can move on to the field visit or site visit. So once the site visit is done, the preliminary subsoil investigation will be conducted, and then based on the results obtained from the preliminary ground investigation and based on the observations made during the site visit, the engineer can prepare a preliminary soil report, okay, or the initial soil report. And once that is made, then if further recommendations are given in that report for further ground investigation, or based on the complexity of the project, if further ground investigation is required for that project, then we will move on to the main ground investigation part, where more laborious field test will be conducted. And then once that is done, uh, the engineer has to present a final soil report with a proper recommendation for the foundation, okay. But the whole subsurface exploration program doesn't really end with the submission of the final report. The engineer can monitor the work or monitor the condition of the site during construction and after construction as well. So these 2 points are also highly important, and they also form an important part of this exploration program. So their responsibility of the engineer doesn't really end with the submission of the final report. He also has to make sure that his designs are implemented properly, and that there are no failures observed in the site, because he only gave the recommendation for the foundation. So that is why the monitoring during construction and after construction works are highly important in an exploration program. So as shown in the flow diagram of the exploration program, the first part of, or the first stage, is desk study. Now desk study is a very important part, as is all other stages. It also forms a highly important part of the exploration program. And please don't think about skipping this part and then moving on to site visit directly, because it is always good to know more about the site, and make yourself thorough with the already about the site with the already available materials regarding the related to the site. So therefore, see, initially when the client approaches the engineer for a particular project, he it is always a task force. So definitely the team will consist of the design engineers, and then the site engineers, the supervisors, and your responsibility, all the responsibility of the task force is towards the client. So everyone has to sit together and discuss about the project very well. So already the client will have certain requirements, and based on his requirements, the design engineer would have already worked out something related to the project. Maybe he would have already um, uh, uh, done some preliminary drawings or sketches or plans. So or mainly the design concepts will be known to the design engineer, okay. So it is very important that everyone related to the everyone within the team should sit together and discuss about the project. What is the expectations, what are the requirements, what is the budget that he is planning, what the client is planning to keep, and then what is the time frame that within which he wants his project to be completed, and so many requirements of the client and design engineer should be known to this geotechnical engineer as well. So that is why I said it is always good to discuss with all the team members. And other than that discussion, what is important during desk study is that you have to collect as much information as possible regarding the site. So where do you get this information regarding a particular site? Obviously you have to visit the government offices for records, because they might be already doing a yearly survey, or they might be keeping some records related to earlier tests done on that particular site. So related documents should be collected from all those government offices. And then obviously you should try to collect aerial photographs of that site. And very importantly, you should get the maps of the site. Okay, so both topographical as well as geological maps will be highly useful for you. So geological maps, especially since you are going for a subsurface exploration program, if you have the geological maps with you, it will be highly useful during the exploration program. And you will be able to have a comparison with that. So basically, collect as much information as possible related to the site, and then go through all those materials, and then make yourself thorough with the site, okay, before you actually make the site visit. So once you do the desk study and then you move to site visit, you will be having a vague idea about the site there itself. Okay, so that is why I have highlighted that desk study should never be underutilized or underrated. This part of the exploration program should also be given equal importance. Okay, now let's move on to the next stage. So now our desk study and our homework is done regarding the site. Now let's make the site visit. So second important stage of exploration program is the engineer with his team, with his geotechnical consultants, he'll go to the site, and then what will he do? Basically, you go to the site and to assess certain features related to the site. Now, most importantly, when you have a land with you, you go there and you try to observe all the features that is already existing on the ground. So ground features are very important. So as I have mentioned in the previous video also, because it is highly important to plan your construction activities, and to plan and also to finalize the plan of your project. Okay, because there will be already existing drainage, sewers, and some electric post. Then there will be other obstructions, maybe remains of certain old buildings. So you never know, there may be many ground features existing on that particular site. So you have to note down all those features in your book. And then obviously, if you get a chance, you should definitely talk to the local residents who are residing nearby, because again, it is based on the project. It can be an industrial project, it can be a commercial setup, it can be a residential plot. So whatever it is, it will always be good to talk to people who are residing nearby, if there are any. Okay, so they will also give you an idea about the frequent events that occurs there, or if at all there are some possibilities of any natural disasters that affects them, or any other issues that they face, any other pollution related matters, whether they have experienced any contamination before around the area. So all those questions can be asked. So basically, it would be nice if you like a good questionnaire survey would be good with the local neighborhood, and you will also be able to collect many details from that conversation with the local residents. And obviously, and importantly, you need to have an idea about the ground, the water bodies, if there are any existing uh, on the site as well as nearby the site. Okay, so that is also very important. You'll get an idea about the groundwater table. From that, you will get so you will know because if you have an idea about, since you have already talked with the engineer during the desk study, you will have an idea about the plan that he has already made in his mind. And based on that plan, and you can think whether there is going to be an effect uh, on your structure due to this water body. You can assess the distance. That is also very important. Distance of the proposed structure from the water body, that is also very important. And then, and another important thing for a construction work is to work out the transportation routes. So you can assess the transportation routes, because most of the times you have to bring a lot of construction materials from far away places. So there has to be proper transportation routes, to your site. And if at all your site doesn't provide you with that proper access, then you will have to maybe you have to maintain that you have to make a proper access road into the site. So all these are very important features. Okay, all these are very important things to be noted, and then you have to take necessary remedial measures for rectifying that if there is an issue with the site. Okay, so if a proper access road is not there, and you also have to think it in this way, that a truck has to go through it. Okay, a truck of this size has to go through that access road, because it has to deliver a lot of materials to the site. So the road width should be adequate, road access should be proper, there should not be any obstructions in the way. So such and such things you have to make sure it is all eliminated from the ground. And sometimes from that itself, you sometimes maybe during the site visit itself, if it is that bad a site, you can give a suggestion to your client for completely discarding it. Okay, or you can sit down and still have a conversation with him about thinking about some other site. So that is why I said in site visit also you will be able to take many important decisions. Okay, so once the site visit is over, we move on to the next stage, that is a preliminary ground investigation. So if we are about to conduct a ground investigation or a subsurface exploration program for a project which is about to be constructed, then it is highly important for us to assess the subsoil characteristics. Okay, so that is what is going to happen in preliminary ground investigation. So there are various methods of subsurface exploration. um, Based on the type of soil, you can recommend a suitable test. Okay, not all tests are suitable for all types of soils. So based on the suitability of the soil, you can recommend a test. Okay, and I'll show you the various methods of exploration or various tests which are usually conducted in the next slide. So usually we'll choose one of these exploration tests, and then what we do is we assess the subsoil profile, or we need to know the stratification. That is a layer. If the soil is existing in layers, we need to know that stratification of soil. Then from that you will get an idea, and from each depth you can collect samples and send it collect representative samples. That is very important, because the sample whatever you are collecting should be properly taken and should not be, most cases we always prefer a undisturbed sample. So anyways, we'll look into all those things in the latter classes. So basically, from various depths of the exploration, you collect samples, pack it properly as per the packing requirements, and then you have to send it to laboratory. You will do all the index and engineering property tests whichever are required. Mostly you will have to do everything if you are going for a highly complex project. You have to conduct all the tests, all the laboratory tests, and then from that, definitely from the results obtained for the type of soils which you have collected from the site, definitely the engineer will get an idea. Definitely he will be able to infer from the results what type of soil it is. Is the soil suitable for the foundation? Does it have enough shear strength? So all those initial knowledge about the soil will be known to the engineer by now. And then what he should do is he has already made his desk study, he has already conducted his site visit where he have got a pretty good idea about his site. So now he will be able to give a detailed description about the site in his preliminary soil report, as well as he can present the results of the soil which he obtained through laboratory test, and also the method of exploration he conducted, and then comes the results of the soil based on the laboratory test which was conducted on the soil. So he can definitely, with those results, he can give some recommendation for the foundation for the proposed structure. Okay, with those results. So but we cannot say that this is the final result. We can never say that. Maybe during a site visit itself, if he would have anticipated some mega issues, then he can inform the design engineer, and then suitable changes in the design can also be made. So all those recommendations can be given in this preliminary soil report. Okay, so basically all the description related to the site, and the initial exploration test he conducted, and the laboratory test results, everything can be reported, as well as a initial recommendation for foundation can be given based on those results. And later what we do is, and he can mention the design changes to be made, if at all it is to be made. But those things can be mentioned in this preliminary soil report. But sometimes based on the complexity of the project, like if it's a big project, it's a multi-story structure, and maybe just preliminary ground investigation or exploration test may not be enough, you might have to go for a second round of exploration test which can further confirm these results. Okay, it's like a validation to be made. For example, maybe based on the initial test results, if you are planning to give a pile foundation, okay, uh, if you based on the initial report, based on the initial results, if you are planning to give a pile foundation, then what you should do is, and in that report, definitely this engineer would work out the pile capacities based on the depth at which it is going to be located. So those and all, the design, the geotechnical engineer can give recommendation. But then as a second stage, what as a second stage, what he should be recommending is an actual pile load test in the field, okay, to validate the capacities which he worked out. Okay, so he worked out the pile load capacities based on the results he obtained from the initial soil laboratory test, as well as the exploration test parameters. Okay, and now based on that, he worked out the pile capacities. But to make sure that the pile actually is going to carry that much of load, you have to conduct an actual pile load test in the field. So that pile load test will come under the main ground investigation. Okay, so that is why I said, so if at all a second ground investigation is to be conducted based on the requirement of the project, then that will be done under main ground investigation. Okay, so through our syllabus, we will be covering all these different types of exploration, subsurface exploration methods. So I have just given you an overview of all the different types of tests through this diagram. And we have open pits as one of the exploration methods to assess the soil profile. It goes up to like 2-3 meters maximum. Okay, not more than that. Then we have boring techniques. If we have to assess the soil profile to greater depths, we go for boring techniques. So these are 4 other different boring techniques which we will be covering. And then there are something called as sounding methods, where we will be, there is standard penetration test and cone penetration test. So these tests will actually give you the resistance of the soil to the force applied. Okay, that is what these tests give. That is why it's called as penetration. They penetrate into soil, and soil exerts some resistance. So that resistance will be noted down in terms of a number or a value. Okay, and then you have field test. So there are some in situ tests which will be conducted, and mostly this comes under the main ground investigation. There is pile load test, plate load test, pressure meter test, and all. And then we have something called as geophysical methods. Now in geophysical methods we don't do any kind of boring. Okay, without boring itself we will be able to understand the soil profile. So we are moving on to the final stage of the exploration program. So as I said, in the preliminary soil report, the engineer can give a initial recommendation for the foundation based on the results and inferences that he drew from the test results and the field test results, laboratory and field test results. And further, if the project requires the next level of exploration, then we have to do that under main ground investigation. Okay, so whatever in situ field test, like I said, if pile foundation is to be given, then it has to be validated by conducting a pile load test. Okay, that is whatever pile he has recommended, the it has to be one or two has to be constructed at the site, and then those pile has to be loaded, and they have to see whether the load capacity that is obtained from the field test is matching with the load capacities which the engineer has worked out in the preliminary soil report. Okay, so that's a validation which is done. And then finally, once all this tests are conducted, then he can give a final report. He can make a final report submission. Okay, and there he has to properly give a foundation recommendation, and he can mention the construction techniques to be adopted, like if anything extra other than the conventional techniques are to be adopted, then those techniques can be mentioned there, and any other changes in the design to be made, or any other further provisions to be made, or any other precautions to be taken. So all those things can be mentioned in your report. Okay, and so as I said, once main ground investigation is over, you submit the final soil report, and further you can monitor the works during the construction and as well as after the construction works also. Okay, so thereby you will be able to ensure that your design is proper and everything is working out smoothly without any notable failures. Okay, so this is what the engineer has to ensure with the project. Okay, so this is it. This is how our exploration program works. Okay, so thank you.